Well, thank you all very much, everyone in person, which you cannot see because you're on my webcam pointing towards me, and then everyone attending virtually. If you don't know me, I'm Zach Gardner. I'm one of our senior consultants here at Keyhole Software. And if you didn't know, today we're going to talk about a very exciting topic, AppDev security. That's why I played some very upbeat music beforehand, kind of get everyone in the zone. Because security, it can be fun if you think about it. The best part of security, honestly, is if you never get into the news. So like one of my goals for you all as part of this presentation is make sure I never see your name or any application you work on in the news. Like that is a sign of a very successful security model. So to get started with, I have been developing software for a very long time. I started doing web-based software back before we had debuggers or anything. So we just had to do alerts for whenever you wanted to fix mistakes, see what a variable was. And I've seen a lot of different stuff over those years. Currently, I'm a consulting for a large hospital system in New York City, working to make healthcare more affordable for patients and less crazy for providers. Your doctors have a very tough time. So with all the EMRs they have to use, so make sure to thank them the next time you see them. We do stuff in Azure, GCP, .NET Core. I've done PHP. I've done Java. I've done SQL, MySQL, NoSQL. I've done server administration. I hope to never do that one ever again. I've seen a lot. I've seen a lot of just really interesting things, a lot of interesting approaches over the years. And just so you know, my biases, I might come off as an optimist, but I'm actually not. I'm really a pessimist. Sometimes. Most of the time, though, I'm a pragmatist. It just kind of depends on it. So today, I'm feeling a little bit more pragmatic. I care more about, getting things done than viewing the world through, either of those lenses. I'm not one of the architects or, one of the developers that's really into like hardware. I don't have like 15 computers that I'm restoring. They're like antiques. That doesn't really get me going. What I really like are figuring out how to solve business problems. I like getting into users' heads, getting into the developers' heads, and figuring out how we can marry those two together. And total disclaimer, which might be refreshing, I am not here to sell you a single product. I'm not here to sell you a device. Like none of that. This is not a sales pitch. This is egalitarian. This is for your benefit. And I want to focus only on new things. I, as an application architect, spend a lot of time trying to research security, see what's happening in our industry. And a lot I run into is more from like an enterprise perspective. You have the NIST cybersecurity framework. All these things are great. They're more oriented towards, across an organization. How can we keep things secure? But we, as application developers, we're building the things that go inside of these organizations. Like we're actually building the things that like end users are using. So security definitely doesn't stop or start with us, but we are as much part of the conversation as like an enterprise networking group or an enterprise identity access management group. So it's my shameless pitch. And all of these images are generated from an AI. I got access to DALL-E, and then I kind of blew through all my credits before I could come up with some good images. So sorry, it's not quite as good as DALL-E, but it's pretty good. So just kind of get everyone oriented. There's a lot of different things that you could be doing with your day other than listening to me. I'm very happy you're here. Like, don't get me wrong. But especially in tech, there's so many different things that we could be talking about instead. Like NoSQL or cryptocurrency, tons and tons of stuff. But I was watching an interview from the CTO of ThoughtWorks, which is major consulting firm. They like microservices, like that's them. And the CTO of ThoughtWorks, when she was interviewed, she was asked, well, what should CEOs, what should tech leaders really be tuned into? Like, what's the number one thing they need to be thinking about? And like immediately, she said cybersecurity. Especially during COVID, if you think about it, most of the restaurants we went to, they were just like rinkety old sites, but now they have like e-commerce interfaces. Like everywhere you go, everyone has had to have a digital presence to get through the pandemic. And now that's just a huge surface area for everyone to start attacking. And the more and more that you read about things like SolarWinds or other, compromises, this stuff is real. These people are out there. So I'm not saying this to scare anyone. I'm just saying, understand, this is not an easy part of the job, but just like making good code, just like making reusable components, security is going to be part of our job going forward. And we have to embrace it as software developers. So I thought I'd start out with a fun one. This is a story that literally did happen to me about 10 or 15 years ago. We had a piece of software for schools, higher education, different universities. Well, different universities like their own little, their logo on like every single page. And all universities wanted this piece of software, 80% of it, it's worked the same, but 20% of it had to be different. And they were like very, very stuck on that point. So we as software developers, we have to make a choice. Are we going to make something very configurable, or are we going to make it standard? Well, if the business is telling you got to make it configurable, you don't have a lot of wiggle room. So there's a couple different ways to do it. You could have like big switch statements for, if it's this college, do this. If it's this college, do that, which works for a while until you get like 50 different universities because your sales team is so successful. And then you end up being like, well, let's just throw that out the window. We will, at runtime, figure out what college we're on, and then we'll pull in some code from the database and then run it. Now, this seemed okay at the time, and it works for a little while. But when you make software so configurable that the way you approach it is to evaluate code at runtime, you're opening yourself up to a huge can of worms, because the source code likely isn't tracked, something like Git. It's likely not being scanned for vulnerabilities. It's very fragile to change. It is customizable. Like, don't get me wrong, there's a lot of different ways to skin this cat, but you're really opening yourself up to a lot of bad conversations that you might be having with legal counsel. If a malicious actor were to get in there, you're essentially giving them the access to do anything they want in your system if you're doing this kind of thing at runtime. So any place where you see like an eval or any sort of a parallel way of running code at runtime, there's likely a better way of doing it. Now, what we opted for is, maybe you have a configuration for each college, and maybe it has inside of there a flag saying, well, this college supports this feature. So then in your code, you're not checking, which college am I on? You're checking, well, does the college that I'm on support this feature? So it's more of a feature flag approach, and allowing that is a much better way of solving the business problem than doing this over customization. We can also push back as software developers too. We have a lot of knowledge about what works and what doesn't work. So if you run into scenarios where your product owner or your BA is asking for something and you're like, hold your horses, like I've done this before, like are you sure they honestly need this? Maybe it could be a phase 2, or a phase 3 approach, or a phase 15. If you can push it all the way out to phase 15 and then they're happy and they never get to even pass phase 2, they probably didn't need it to begin with. Next, and this kind of goes into me being pragmatic. REST used to be all that we talked about 8-10 years ago. We wanted everything to be RESTful. Well, there is no REST specification, but there's sort of a generally accepted view of what REST is. And how you would, in this example, search for a patient. You would call like my API /patients, and then you'd pass on the query string, last name equals Gardner, if you were searching for me. Well, like, sure, like that follows the REST specification to a T. But what can happen is that query string gets put in a log somewhere, and you have inadvertently exposed someone's PII in plain text. So anyone that gets that log, they can see names of people. Hopefully you're not searching people by social security numbers. That's something else to kind of mention. Like, if you can, in software development, don't even know someone's social security number. Like, there's just not a lot of good reasons to know it. But if you were to follow the REST specification to a T, you would do something like this, because it has to be a GET, because you're not creating anything, you're searching for something. So what we have to do in healthcare is even we're searching for something, it has to be a post. And then in the body, that's where we actually put the name. So then it's not included in the logs as part of your access to it. You still need to train developers, make sure that they know not to log names. The best way that I know how to train people is pretend that whatever data you're working on is your mom's data. Because you know, if it's your mom's data, you're going to keep that a lot more secure than if it's just someone off the street. Now, REST, you know, it's had its ups, it's had its downs. One of the things that is sort of a knock against, maybe not necessarily against it, but there's a lot of bespoke code that you have to do to implement REST. You have your controllers, you have your services, you have your repositories. GraphQL has really taken off in the past maybe 4 or 5 years as a different way of implementing APIs. So instead of focusing so much on the nitty gritty of, you know, I got some data here, I got to move it to this class, then I got to move it to this class, then I got to push it all the way through. GraphQL allows you to instead define what are the services that you care about. And you can actually compose different calls in very ingenious ways that you might not have even thought of when you were originally developing it. And it's more focused on writing less code for both the UI developer and the API developer. And every single line of code you write opens you up to something bad. That's not to say we shouldn't write 0 lines of code. It's just every line of code can add up. So my other pitch is it's easy to be too much of anything. I can even be too pragmatic at times. So try to take what you want with a grain of salt. You know, try to think through what potentially could happen in the future. And one of the things that I hope none of you ever do is roll your own authentication. Like, I know it's so much fun to roll your own authentication. You know, you get to be like a real software developer. Like, you get to feel like you're actually doing something because it's a ton of code to do it right. Like, don't get me wrong. You really open yourself up to a lot of nasty things. Because most of us, when we work on applications, we try to understand what's the business problem. You know, I need to enroll students in classes, or I need to transfer money from one account to another. Like, we understand like business problems. Most of us are not full-time security engineers. We're not there doing like pen testing 24/7. That's not our job. It's easier to pay someone. It's the same idea with managed services versus running your own VM. It's so much better to pay someone to do it that has a full-time team that's watching this kind of stuff, doing threat detection, that has actually tested all of their security code in various scenarios, and they understand vulnerabilities. It's much better to do that than to try to roll it yourself. So, you know, don't roll your own authentication and authorization. Use a library like Spring Security, or if you're on Azure, MSAL. If you're doing JavaScript arithmetic, which, you know, you have my condolences, it's not a lot of fun. Use Big Number. Don't try to write your own. If you are making a form builder, don't write your own form builder. I've made like 5 form builders in my career, and I don't want to make a 6th. You know, no one would ever consider writing their own database. There's absolutely no reason to do that in 2022 unless you're like SpaceX and you have like some really weird use cases for needing to calculate like geography on Mars or something like that. If you're not doing that kind of stuff, you would never roll your own database. So don't roll your own, like, friends don't let friends roll their own authorization and authentication. Network level security. In the good old days, and I can say that because I have gray hairs now. So, you know, I'm sort of, I'm elevated to, you know, 20 somethings, you know, I barely remember what that was like. But in the good old days, we had these giant data centers, and they had like walls, and they had like redundant power. They had like redundant power to the redundant power. They had like 4 different internet connections. And you were sure that anything that got in that data center, it was secure. So we could do things that we might not really, we knew they weren't a great idea, but we're like, oh, you know, no one's ever going to get to this server. There's no way the outside world can get in. Now that we're on Azure, we're on AWS, we're on GCP, you really can't trust some of those things anymore. So homework, if you want it, the zero trust model, what it means is don't trust anything. Like whatever you do, don't trust anything. And when you have that kind of mentality, you start thinking through like, what are all the different ways that a bad actor could get into my system and, wreak havoc? And if you have all these services out there running on Azure, it's not enough just to do authentication. What you have to do is actually protect it at the network level. So let's say this actually happened, I think it was this year. Cosmos DB, one of the most popular NoSQL databases in the world. Microsoft had a vulnerability where you could call an API and you can get connection strings. So all of these Cosmos databases. Now, they say, allegedly, that no data was compromised, like, they caught it before anything. But do you really want to be thinking about that as you're rotating out those connection strings? I didn't. And you know why? It's because I protected that database at the network level. So even if that connection string got out to the world, even if it was on a billboard in Times Square, for someone to, sit there and like wait for the numbers, scroll around, like type in, you couldn't have done anything because the resource said the only thing that can connect to me are things on my virtual network. A VPC is the analogous resource on AWS. But when you have these virtual networks, you have this network level security, it's like having a moat with like fire around it and then alligators that jump from the fire back into the moat and back and forth. Like it protects you. There's no way to get into this thing unless you're inside of this network. So it is not something that I've seen most people do by default when they deploy resources up to the cloud. And honestly, some of the defaults that they have in places like Azure and AWS leave a lot to be desired. And we'll probably see some of this stuff changing as the culture changes around security. But there are costs to doing network level security. If you have all these resources out on Azure, you might have different tiers of them. You might have like a VM that has, like 5 gigs of RAM, and then you can scale it all the way up to different tiers. To use network level security, oftentimes what you have to do is bump it up to above a free tier. So the downside is that the operational expense of our applications is going to increase. The upside is that because we are paying that price in network level security, our intellectual property of the data of the company, which is sometimes their most valuable resource, is protected. So it can make things harder to debug. It's not fun to set it up. And most of us as application developers, networking is something like we kind of understand. Sort of like magnetism, like I know how magnets work, kind of, but I don't need to know. Like I can pay like a magnetic expert to do it. Same thing with network people. They're great people, they're lovely people. I'm good friends with a lot of them. Let them help you secure your applications. Kind of going back to the culture shift. It seems like every day there's something new in the news about some company that has had their application hacked or some ransomware that's gone into it. It's slowly, Hacker News, is a great litmus test of where the community is. It seems like every day there's at least 1 or 2 things on the front page. And we as software developers, we can either be changed by it or lean into it and start to change the culture. Because good software, honestly, is not developed in a vacuum. Like, if someone was sitting right next to me, it's still hard to make software when we're that close. Now we're all spread out. Now we're all remote. Now communication matters more than anything. And how do you build a culture where people actually are thinking about security as they're developing it? UI developers are often the first line of defense. They're the first one to use our APIs. And if they have, maybe they'll ask their API developer, like, are you sure you want to do it like that? Are you sure this is the right way of doing it? Those kind of subtle little things start adding up over time. And eventually, I think where we might be in 2 or 3 years is security is probably going to be as crucial to our applications as the user experience itself. And along with our application teams having, API developers, UI developers, DBAs, UX designers, I think there might be a security engineer or a security architect working on these cross-functional agile teams that is constantly there asking the team, are you sure you're doing this right? Reviewing security blueprints. That it just is probably going to start becoming more and more part of our culture as software developers, where when I started, I mean, it's something that would have never even crossed my mind. And as part of that, junior developers will often go to Stack Overflow. And a little behind the curtains, senior developers go to Stack Overflow even more than junior developers. It's impossible to remember all this stuff. Like, I've been doing JavaScript for like 15 years, and I still have to look up how to like remove an element off an array and then not have a blank spot in it. Like, you know, it's okay. As junior developers, they'll find out like we do this stuff too all the time. And you really have to be careful about the advice that you get on places like Stack Overflow or blogs, because they will often show the happy path. They'll show like the dead simplest way to get something set up, which is good. But one of the things that I try to do in my blogs is be like, all right, so that I will say, this is the easy way to do it. Don't do it like this in production. You want to have things like credentials stored in like a key vault or a secret service. I wonder, is that the name of it in AWS, is secret service? They're probably a bit confusing with the actual like US secret service that does. You know, they also check currency. Like, they're into like counterfeiting. So like, if you do like counterfeit bill, the secret service investigates you. Anyway, sorry, I have someone I know that's in the secret service. The better way to do it is not to use username and passwords at all. I mean, it's 2022. We got a rover on Mars. We shouldn't be doing username and passwords in the credentials. What you can do instead, is a couple approaches. The way on Azure that they typically do it is what's called managed identities. So you'll have this service sitting out there that needs to connect to, let's say, a database. The database, when you configure who can connect to it, you'll actually say like, allow connections from this resource, from this web app, from this Kubernetes instance. And all the connection string is from that resources side is just, here's a FQDN of the database, and that's it. There's no username, there's no password, like there's no nothing. And behind the scenes, it uses the ability to say like, oh, well, I know this network traffic is coming from this place. I know that it must be this thing. I know it's been granted permission to this. So it's all behind the scenes, and it's all completely seamless to you. And you don't have username and passwords to manage anymore. Now, the way they do it on GCP is a little bit different. You can do service accounts, which still are kind of username and passwords. You can get into like federated trust. Whatever you do, try to get away from username and passwords. If you have to do it, which sometimes the services just simply aren't mature enough to allow for managed identity, things like that, you have to periodically rotate these things out. You know, just like we all have to change our passwords, whether we like it or not, and I'm in the not category, it's just something that has to be done. So take whatever you're doing with a grain of salt, start with like the most secure approach, which would be managed identity, and kind of, you have to ration yourself down, like rationalize why you can't do it. A surface area, I think this was supposed to be a picture of clouds and the sun. It didn't quite come through. We'll edit this out in post-production. So one of the things that I have started to get more into is code analysis. There's a ton of different tools out there that actually let you analyze your code and find either very obvious vulnerabilities like SQL injections, or using dependencies that have known vulnerabilities. It can also kind of catch things that might not be immediately obvious, like bugs where you're calling a variable one thing, and then in another method it's called a different thing, and then it flips back to the first, where you open yourself up to getting confused about these things. There's probably the most common tool that I've seen is SonarQube, but there's others like CodeDX. I'm sure I'm forgetting a bunch off the top, but they allow you to give it your source code, run it through a bunch of different algorithms, and then view the output. I wouldn't recommend putting that as part of your build pipeline in so much as you check code in. It has to be run through this tool before it even goes to dev. Because what we like, that's actually where we started, is we went through all these static code analyses before we'd even allow it to deploy to our development environment, which is good when you only have one thing that you need to run through it and it only takes like 2 minutes. But we were waiting hours for that entire pipeline to go through just to push something to our development environment. So we're like, this is crazy. Like, it's good that we're doing this, but it's inimical to our actual goal. So what we do instead is you can do a nightly build of the code and have the output emailed to you in the morning. It might come in at 1 or 2 a.m. So make sure you have your do not disturb if you have your work email on your devices. But just it's something that you see every single day. You don't even have to do it every day. You could even do it between releases. Maybe you want to, as a gatekeeping check, make sure that you don't have any critical vulnerabilities. That's totally fine. Doing something is better than doing nothing. And a lot of these tools are free, which is the crazy part. You might need licenses if you use, it's like more than like 5 million lines of code for SonarQube or something like that. I mean, unless you're doing something rather like a large government site or something like that, you're probably not going to run into those limits. And it allowed us to actually see a lot of other sort of anti-patterns. Now, I have a lot of beef with Node.js. I will just be honest and say it. It is not. It leaves a lot to be desired. I'll say it like that. And one of the things I don't like about it, it's not even Node.js, it's NPM, because you can do fuzzy versioning of your dependencies, which is really cool, like when you're getting started. But as you have an application that grows over time, what happens if a malicious actor takes over one of the dependencies that's like 7 downstream from something that you're actually bringing in? Well, if you're using fuzzy versioning, guess what? You get that. It's like a nice little Christmas present, on your front door. And you might not even know about it until you see it in the news or if you're monitoring a CVE. So you get these fuzzy versioning. You can get dependencies in, you can get changes in you never even knew existed. So the harder way to do it, and the way that you don't see a lot of blogs do it, is to do very specific versioning. Now, that means if someone upgrades, you have to go through and upgrade your package lock file. Like, sure, that's just the cost of doing business. It's much better. Like, pretend it was your mom's data, again, that you're working with. If it's your mom's data, you're going to keep that thing secure. And in addition to that, one of the other tricks that I've picked up on recently is using Sanitize. So everyone's probably at this point filled out like a Survey Monkey or like some sort of like online form where it has to collect data. What I heard, allegedly, was that a malicious actor was able to put in a link into, let's say, like the name field. So that form got processed, it went through, and then it emailed someone to review the results. Well, if the email contains that link that that person put in, and you didn't sanitize it for like HTML entities or anything like that, a user could click on that, and then they could go to some nefarious former Soviet Union countries' websites, and then, it's a phishing attack. It's a spear phishing attack from something as simple as collecting data and then emailing the results to a business person. Now, this is where our enterprise friends come in, because we as application architects, there's only so much that we can do within our application. But there are some things like email that cut across the entire company. So being able to test stuff like this to make sure that the email encryption is working, making sure that like link protection is working, all that stuff is something that we on the application side have to do. But it's often the enterprise side that we need to work with that are actually the ones to implement this kind of things. And enterprise architects get a bad name. I love them to death. They think about a lot of things that we on the application side don't, just because they have such a broader perspective. They get to see trends that are coming that we might not even know about until it becomes a requirement. And one of them that I've picked up on is payload encryption. So if you think about the API calls that we used to make back in the day, it was all over HTTP, It was all in plain text. Like, it's cool, dude. No one's going to intercept that. But then people intercept it, not super fun when that happens. So we all have to switch to HTTPS. That's fine. API call using HTTPS is good. It's encrypted. Life is good. What a lot of other industries, and this is one of the advantages we have at Keyhole, is we get to see what other industries are doing. FinTech is actually, I think, going to be the pioneer of this. They do payload encryption. So not only are you using HTTPS, they will also encrypt the payload of like a post or a put request, which might be a little bit overkill for a lot of scenarios, because you have to, on the way out, encrypt it, and then when the receiver gets it, they then have to decrypt that body and then serialize it over to whatever they were using. One of the advantages is that it prevents against a man-in-the-middle attack or a woman in the middle. This is 2022, and I have 2 girls, so I try not to use that language. And it allows you to also have to worry about things like rotating certs, because everyone loves to rotate certs. I do it once a year, and I forget until the week before they expire, and then I have to remember, like really quickly. But it allows you to also have a culture of security, because if you're doing payload encryption, that's going to be part of your standard processes. You're going to start thinking about what are all the other ways that we might be, that we could do things differently and make the application more secure. So it by itself might not protect you against everything, but it actually starts you thinking about what are all the different things that could go wrong and trying to prevent against that. And if you've ever been on a long project, like the project I'm on, I've been for 7.5 years. It's probably the longest I've ever been on any project. We have code that was written maybe like 6 years ago, and it hasn't needed to be updated since then. I'm sure all of us, if you work on a project for any amount of time or have come to a legacy project, you probably experienced something like that. Well, let me tell you, it is a lot of fun trying to figure out at 7 p.m. on a Friday night how to update some code because someone found a vulnerability in it, and you need to get that thing out to production before the sun sets or the sun rises on Saturday. You need to stop the damage. It's a lot of fun. You get to, your heart rate goes up, your adrenaline goes up, you start sweating. It's a great experience. It's a great way to lose weight. It's not so great if you want to have a really good work-life balance. Now, there's a lot of code out there that we've written. And one of the strategies that you can do, it actually plays in with the code analysis part of it. Periodically build all your code. Even if there's no changes to it, you don't have to deploy it. I'm not telling you to deploy things to production that you haven't tested. I would never do that. Junior developers, that does sometimes happen. It happens so much. But we shouldn't do that. If you're always building your code and you're always running it through a static analysis tool, what you're going to find is about a year, maybe 1.5 years after the last commit, the build is going to randomly break. And it's going to be something weird, something that you would have never thought of, maybe a dependency updated because you didn't take my advice and you're using fuzzy versioning. Or maybe a tool has been deprecated, maybe your license isn't good anymore. It is so much better to find that stuff out when you have time. You can get into the office, see that a build has failed, go to the Keurig, make a cup of coffee, kind of wander back to your desk and then fix it. As opposed to, you have to drive back home from your kid's soccer game because you got an on-support call and no one knows how to build this code anymore and it needs to get fixed. So it's actually killing 2 birds with 1 stone. And there's so many tools out there to do it that is something that should be part of all of our software development life cycles. Now, tools are great. Tools are never a goal, but they're always something that help us achieve the goal. What I found is that some of the tools we use can actually be harmful to us. The one that I pick on, even though I love it, is Postman. Because when you go to Postman, it asks you like, oh, let me log you in so that we can record all of the API calls that you're doing. So if you ever go from like one machine to another, you don't have to carry anything over. It's just you log in and it brings through all that stuff, which is super cool until you need to test something in a pre-production environment and you're using live data. Well, if you put that in your Postman collection and you're logged in, guess what? All that data, it's left your machine and it is now at the whims of wherever Postman stores. So after we're done with this, if you're using Postman or Insomnia, as the kids do these days, sign out, delete the data, and don't ever sign back in. Because that little helpful tool can expose your data, to expose your mom's data in ways that you really, really, really don't want it to do. So just be aware of what environments contain production level data, maybe even have a repository of tools that are approved for developers to use that have to get vetted out. This is a good enterprise security exercise. Just make sure that, that there's no surprises when it comes to what tools you're using. My other public service announcement about Postman is also don't let your certs expire. And I'm going to say it 2 more times. Don't let your certs expire. Don't let them expire. Even intermediary SSL certs. We had that happen and it caused a production outage because people didn't have it on their calendars. People weren't aware that these certs were even going to expire soon. It's one of the coolest parts about moving everything over to HTTPS is that we now have to worry about when certs expire. So developers might not have to care. I would say a DevOps team or a site reliability engineering team, or even your Scrum Master, just make your Scrum Master do it. They love doing a bunch of random stuff. They're the nicest people in the world. Make your Scrum Master record when you get certs, when they expire, put tickets on the Jira board or the Trello board or whatever else the youngins are using these days. Just put it somewhere and just constantly make sure that you're refreshing your certs. Because if you don't, users are going to get a big red old box. It's going to be a lot of calls. You have to talk to VPs and stuff. How did we let this happen? It's a lot of fun to go through those conversations. Now, it's something super simple that everyone on every team can do to help. And it does sort of cross the borderline between, what's an enterprise responsibility, what an application responsibility is. I would say, if you don't think it's an application responsibility, wait for it to happen, and then it's going to quickly become an application responsibility. The other big thing that I think most teams could use is honestly training for developers on what can and can't be logged. We had an occurrence of someone logging a username and password that someone put into a form, and it logged it in plain text, very searchable. It was a fun exercise, and I use the word fun lightly, less lightly than I've used before, to find all the different things that can go wrong. So if you're logging PHI, now you can't do that. If you're logging PII, shouldn't do that. There's credit card numbers, don't log those. It really depends upon what domain you're in for the things that you should and shouldn't log. There's no one list that I or honestly any other person could give you that would tell you these are all the things you need to worry about. A lot of this security stuff, it's hard, and there's just no way around it. There's a lot of things to consider, but there are different ways that you can make your life easier by using automation. One of those is using a SIEM. That's how I pronounce it. I don't know if that's right, a SIEM. SIEM seems to be right. And what it does is it's a piece of software that sits there and monitors the audit logs, the application logs. It monitors all the logs that your application produces. And Microsoft's SIEM, Sentinel, it's nearly free, honestly. It's pennies on the dollar for what it can do. It can sit there and look for things like suspicious login activities, or just sort of odd usage patterns of a user who normally doesn't do stuff, or maybe someone logs in at 3 a.m. on a Sunday morning. Sort of just weird things that occur. Now, it's not good if these things happen, and it can report out, but you have to make sure that it's configured. So you have to actually go the extra mile, put off your developer, I need to be lazy hat, and put on, the sort of, I'm going to make sure this thing works before it goes into production hat. And you can ABC, always be scanning. It should be ABS, but I honestly like ABC because it's, it was that Alec Baldwin movie back in the day where he's like, ABC always be closing. The SIEM is one of those areas where the application and the application team and the enterprise team kind of come together, because you probably have an enterprise team that you don't know about. There's probably teams that are sitting there monitoring logs from all these applications. But we, as the application developers, we know our application best. We know who our users are. You know, some of you have even had the privilege of talking to real users of your software. It's crazy because people actually exist, and they're all nice people, and they're, you know, very patient with us. And we have to do the same to them. We have to be caring about their application and the data that they're putting into our systems to collect. So don't worry about, you know, being mean. If you need someone to be mean, just let me know. Like, I can be the mean person, even though it doesn't seem like it. And make sure that you have these systems in place, that you're not going to be scared about these things as you're going to sleep at night. Now, I went through this list in about 40 minutes. This is maybe like the top 15 greatest hits of a list that I have that's like 200 items long and growing. Like, I'm constantly like listening to things on, you know, the Institute for Technology, like cybersecurity framework. Like, I am attending these boring meetings, at least they're boring to me, so that you don't have to. So that if you want to, you know, you can contact us at Keyhole Software. We can do a security assessment. It's not a guarantee to fix every possible thing. If anyone ever sells you something saying, oh, this is going to solve all your problems, it's probably going to solve like half your problems, like for a day or two, and then you're going to have more. Security is something that's constantly changing, just like business needs. They're constantly changing. You know, that's why we invented the agile process, to try to address these things as they come up, instead of trying to do, you know, this monolithic process where we try to capture them, because we're never going to do it. Security is something that's changing. And even the list that I had in 2021, I'd say like I've had to add about 30% to it in 2022. Things that I just never would have thought of before have become a reality. It's a game of cat and mouse too. The people that want to make our lives miserable on a Friday night specifically, they're out there. They're constantly thinking of different ways to get, you know, your mom's data. And you need to do whatever you can to protect, you know, Jeannie Gardner's data. You know, pretend it's my mom if you don't want to even pretend it's your mom, you know. It's something that you just have to be vigilant about. And we as application developers, we have the opportunity to participate in it in as much as all these other enterprise architects do. So if this is something you're interested in, if you've enjoyed my sort of odd stories and mentions of my various family members, you know, shoot us an email. I keep this list continually updated. If you have any ideas or anything else that we could add to the list, you know, definitely let me know. But it's something that we're trying to evangelize more and more. And, you know, if nothing else, if you got nothing else out of this presentation, stay out of the news, whatever you can.
Nice job, Zach. Very, very informative. Thanks.
Thanks, Dave. Yeah, Dave was actually is one of our managing partners. He actually gave me the video of the CTO of ThoughtWorks saying that cybersecurity was her #1 priority. You know, if it's her #1 priority, it should probably be in the top 10 for most of us. She's a very smart lady. So I will leave it there. Any follow-up questions or anything, you know, contact your favorite biz dev person. And thank you all very much for your time. I hope you learned a thing or two. So thank you very much.